Hey everyone, thanks for joining. Today we're going to actually do a full walkthrough of how to actually build a Near AI. And what's really neat about this is that we're going to blend actually leveraging AI to help us code and put together the project, but we're also going to make sure that we walk through the steps of planning. That's a really big piece of all of this is that as much as AI can write code for us, we really have to be the ones to do the planning for us to get the results that we want to get. Let's walk through this project that we're going to do today using Near AI and focusing on privacy. I'm calling this zero to verified. And what we're going to do today is instead of building like another chat bot or something like that, we're going to analyze a bank statement with private inference on Near AI Cloud. Now, this is a great example because a lot of times financial information, obviously, you want it to be private. There might be things in there that not only are just private transactions, but as a whole, you just maybe don't want your financial information leaked to another provider. So, we're going to leverage the ability to have private inference on this information. Also, too, this is a great use case for AI to actually go in and do analysis over some structured data, which we can get from a bank statement. So let's get started. Let me set the scene a little bit for you here. When you are dealing with sensitive information and sensitive data, the key that we need to focus on is it needs to be able to have privacy in both the user having their data protected, just like how it's being stored and how it's being transferred, but also then like what happens when it goes through AI inference. And Near AI, because it is using TEs, which is from another video that we can link back to, and you can see how TEs work. But trusted execution environments allow us to be able to have privacy for these type of inference, which you don't normally get from an OpenAI or an Anthropic or Google, who might take that information and use it for their own training data. If we look at this, we see, okay, we're going to do a sample thing. We're going to look at some different statements here and see if we can actually figure out what's happening with our transactions. And the way the model is going to run is that it goes in a way where nobody can look. So if you've already seen my video on TEEs, trust execution environments, then you would know that basically it is a private room that the data goes into that nobody can peek in. So what's happening here is that your machine would send the file over TLS, which is again standard for encryption, and then the model, which is sitting inside the TE, can then process that. Uh, the cloud provider, so if it is whomever, who the actual model provider is doing that, and also near AI, cannot read that. So the model provider can't read it, the cloud provider can't read it, no one can read it. It is fully private, so you know that's secure. And we're going to get to that too of how we can prove that. So keep that thought in mind. How can you prove it? So we have something called attestation. Attestation is the enclave that produces that cryptographically signed piece of evidence that says this hardware is secure, this model is running inside this secure hardware, so on and so forth. That's the proof of where it ran. Then we want to have the per response signature, which is going to prove what went in and then what went out, which is now you have both sides of this of the where and the what. What are we going to build in this example? This example is going to be fairly straightforward, but we're going to have this into kind of four key parts. Uh, we're going to generate a fake bank statement, so that's easy, but you can also download one from the internet or whatever. We're going to set up a sample localhost server that will actually do all of this. We're going to connect to a model, and from there, we're going to make sure that we're verifying everything that actually happened on that model. And we're going to actually have a front end that actually is going to run and see this. We can actually visualize how this all works. That way, the server can return evidence, the browser can actually show you the correct thing, and you can see this full workflow. Now, here is something that is important. This is really where the lesson begins on how to actually build with AI. We need to start to think about what actually is going to be built. And you can do this two different ways. One, if you feel confident in your ability to decide a tech stack and to talk about it, you can go and define that. If you're not comfortable, these are things that you can actually have conversations with your AI system that's going to do the building beforehand and figure out what might be the best fit for what you're trying to build. Now, the key is though, if you're going to do that or in any form, you have to have a strong specification. That spec sheet is going to really define how this is actually going to work and is this going to be built correctly. Okay, so let's switch to our spec sheet and go from there. Depending on what AI you're building with, whether it's Codex or Claude Code or whatever other system maybe you're using for this, doesn't really matter. If you're using Claude Code, you usually use like a Claude file that will have like your specs, but you just need a spec sheet. So it doesn't have to be a Claude.md. And here we're first going to define, and again, your AI can actually do this. So you can actually have a conversation of using one of the chatbots, and they can help write the spec sheet for you. So don't feel like you have to write this all by yourself. But you again, you do need to know what you're trying to build and be very clear about that. Here's what I wrote. So it's a tutorial app. A user is going to upload a bank statement, and the server is going to extract the text, send it to a model inside of TEE, and return the structured JSON and categorize everything inside there. And we want to make sure that we actually validate that it went through the TE and everything was not altered. And the idea here is we want to show a proof panel, and we don't want it to be a chatbot because then we're going to get into more detail as we go. Typically, then, and again, everyone's a little bit different. So this is just my way of doing it, but you can do it your own way. So we want to have some rules about like what kind of stack we're using. And again, this can be the conversation that you have with your agent in trying to build this, or you can write it yourself by hand. We would then also want to have some facts, and this usually can come from documentation directly. So in this example here for the Near AI Cloud facts, I actually shared the docs from Near AI to Claude. Then from there, it breaks all that down, including the extraction, all of that stuff. Uh, I can then say, okay, what do we want to actually verify? I put in some things I wanted to verify and go from there. Now, once it has its specs and you tell it to build, you should get a stack, if you're using this example directly, something very similar to what I have here on the right hand side. So you might have something that resembles this layout, which is again the standard kind of node project that here's my server, here's my web front end, here's some scripts, docs, things like that, and put it all together. Depending on what you're doing, if you're doing something like in React, if you're doing something in Python, it's going to be structured a little bit differently. But again, these AI systems are obviously more advanced that they're able to go and just determine this for you and they know what to do. The check part was also really important for this obviously because it's a demo, but these are things that we also want to always highlight whenever we are building with privacy is that even if you don't want to ship it to the customer during the development phase, it's always good to have some kind of verification process that what you were doing and what you were testing is actually verifiable. And so we kind of broke this down. And you'll see and when I show you the demo that there are 5 checks here that we can actually look at. And then it's when we can actually even alter and check the validation correctly. How does it look when it's tampered by changing that? And so again, really simple, but it's important to understand that nobody in this path can edit the results without you finding out if you are actually doing these checks. That's the important piece of building with privacy and building with something that is on top of a TE is that you can always have checks. And the end user can even check independently. It doesn't have to be you as the developer. So this is a really important aspect of building with privacy that you can have this part as this is part of it. It does actually highlight though for you that no one could read it. The exact data was sent correctly. So again, it's important to just always remember that there is no rightness in any of these proofs. Rightness comes from separate verification that you may have to do from a subject matter expert or doing your own checks, or depending on what you're doing, that has to maybe happen separately. So let's actually check out what this built and how this all works. So again, let me remind you again how simple overall this is in the prompt to do it. So if we pull up the prompt again, so starting from here of what it was, what I want the stack to be, some different notes and rules around it, some different information about the Near AI cloud and how it's supposed to work. Here's the NVIDIA verification. Here's the how we want the data structured. Again, you can have AI determine this. If you don't know it, if you know what you want or how you want it to be categorized, you can do that. So if I want to know I want these are the categories I want in my transaction analyzer, great. I can write these all in myself, and then what verifications I want to have. This I can give all of this to Codex, to Claude Code, whatever it might be, to go build this and then have something. Here it is, really simple. And I'm going to actually add in a bank statement to show you what it looks like when this actually runs and the attestation part and all of that. Okay, here's my document. It's now going to extract and analyze. And here's our results. So if we look through these results here, it's going to flag some different information about the data. It's going to, it gave me some analysis of what's going on here, some things to maybe look at. It broke down my spending. It broke down the merchants, all of that. I can see all the transactions. All the transactions are here, but we'll go collapse that. And then here's my proof of private inference. So this is the part that I wanted to put in to highlight what we're doing here with near AI and private clouds. And I can see, okay, all of this has passed. Here's what it's been signed with. Here are the different proofs. Now I can simulate actually tampering with the response. So the response of what that's supposed to actually be checked with, I can tamper with it with this test button we put in, and I see, okay, one character changed, the signature no longer matches. So now we say, oh, this doesn't match. This is why having these checks, even if they're silently in the background, is something that you're building is so important that if someone were to modify these results, someone were to be a man in the middle of some sort or whatever, you have that, and it gives you peace of mind to your your users who are expecting privacy all the way through. Oh, something's wrong, you know, then that can be addressed. Restore it back, and you can see everything matches up accordingly. To get a sense of what I used is here's a sample bank statement. You can see this is what I gave it. It broke all this data down. If you've used AI in any form, you probably see that it does really well with these type of documents. This is just a PDF. It can be whatever. But again, that's why we're leveraging the AI to do all of this and to do that work. And that's why we want that private inference to process this information. You can start today at near.ai. Go to the cloud section. You can actually register and sign up. Let me take a second here before we wrap up and show you how to easily get started with that. I'm on the website. I can go down to Near AI Cloud, start building. I'm already logged in. You can just sign in at any time. You can use your email. There's all different ways that you can sign in with it. So just sign in, create an account. You can put money in to actually have credits there. You can also see here that you can actually stake near the near token if you want to do that to actually earn credits as well. If I go to my usage, this is the usage that we just did. I used a newer model, Quen 3.5. You can see how many tokens were just used. It cost me about 2 cents to do that. So you don't have to put a lot of money in to get started, start building. You can just put in a little bit of money. And now my keys, I can go in, I can just go to keys, I can hit create a new key. I can also put a limit on how much that key can spend as well, which is a really nice option. And then just name that and it gives you a key in which that you can then get started and build. If you've missed any of the previous videos on how to build with AI, how to use private inference and routing and things like that, or what just a TE actually is, I encourage you to check out those previous videos and we'll link to those as well. Until next time, I'm Joe, and I hope you learned something. Thanks.